In this video, we are going to learn how to find the slope of a tangent by using limits. So we know the definition for the slope of tangent is the limit value of the slope of a secant at one point. For example, we pick the point P, then in order to find the slope of the tangent at point P, we want to move the second point Q closer to point P. Once the distance between the P and the Q is 0, the limiting value for that slope is our slope of the tangent. So we also call it instantaneous rate of change for the slope of tangent. So they are same. And the limiting symbol is LIM, H approaches 0. Say that is a limiting value as H approaches 0. So the slope of the tangent to the graph y equals f at x at point A. If the x value is A, then the output, just plug in the A value, we have f at A. This is the x and y value at point P. The slope is reservoir run. So another point, we use A plus H, and the y value will be sub in A plus H to function f at x. We have f at A plus H. Then use the x1, y1, x2, y2. We do the difference of the y value, subtract the difference of x value. So simplify A plus H minus A, we have H. So this is our limiting value formula for the slope of tangent. And then after that, we are going to see how we can use this formula to find the slope of tangent for different functions. So this is example 1. Determine the slope of the tangent to the graph of f at x equals x squared at point 2, 4. So this is our point P. And we are going to use our slope formula for the tangent. So limiting value as H approaches 0, then we use the general form. So A plus H minus f at A, then all over A plus H minus A give you H, this formula. And after we find the slope, in terms of A, we sub in the A value equals 2, then we are able to find any points on the graph, the slope of tangent. So we continue to use limiting value as H approaches 0. Then we sub in A plus H to the function f of x. So we are going to have A plus H bracket squared, then minus A squared all over H. We do the expanding, so limiting value as H approaches 0, the A plus H bracket squared, we could use, we rough work, we put here, so A plus H squared is A plus H times A plus H. Then first term in the first bracket times each term in the second bracket. So we have A squared plus A times H is AH. Then we use the second term in the first bracket times each term in the second bracket. So we have H times A is AH, H times H is H squared. Then we collect the like terms, same variable, same degree, so AH, AH. These two are the like terms. For like terms, we just add the number at front. No numbers is 1. So 1 plus 1 is 2. So A plus H squared give you A squared plus 2AH plus H squared, then minus A squared. all over h. Same variable, same degree, they are like terms, so no numbers at front is 1, so 1 minus 1 give you 0, so a squared minus a squared is 0. We have limiting value as h approaches 0 give us 2ah plus h squared divided by h, a squared minus a squared out. Then we continue simplifying. We divided each term by h. We have limiting value. As h approaches 0, we have 2a plus h squared divided by h is h. So 2ah divided by h is 2a, h squared divided by h is h. Then we sub in h equals 0 here. So we let h equal 0 and get rid of the limiting value. So 2a plus 0 give you 2a. So now we know on this graph, all the slope of tangent at a point x equals a, the slope is 2 times a. So for this question, point P is 2, 4. So x equals 2, so the a value is 2. So we sub a equals 2 into the slope of tangent we derived above. So we are going to have the slope equals 2 times 2 is 4. Then this question is done. So from this question, you will see what we have done is step 1, we write the formula for the slope of tangent out. Then after that, we sub the a plus h into the original function given. Then we expand, simplify. We continue do the division, simplify further. Then step 2. So step 1 formula, step 2 we sub in. Then step 3 we simplify. Simplify. Then step 4 is subbing again, subbing h equals 0. And step 5, we are going to base on the x value given to sub in the a value, okay? So the a value, if x equals a number, then the a equals that number, okay? So this is 5 steps. Step 1, the definition of the slope of a tangent, okay? So definition for the slope of tangent, limiting value as h approaches 0, then sub in the input, then simplify, then do the subbing again, h equals 0, then sub in the a value again, then we have the final answer. So this is a first example how to find the slope of the tangent by using the limiting function. So now we are going to apply the definition for the slope of tangent, limiting value as h approaches 0, f at a plus h minus f at a all over h. Use this formula to find the slope of tangent for different functions. So this is function f at x equals negative 2 x squared plus 3x plus 4 at x equals 1. So we are going to do the same thing. Step 5, we sub in a equals 1. Before that, we just sub in a plus h for x, then expand it then simplify, then sub in h equals 0. So you have two sub in. One is h equals 0, another one is a equals 1. So m equals limiting value as h approaches 0, then -2 bracket a plus h bracket squared plus 3a plus h plus 4 minus bracket a value sub in x equals a, plug in a for x, so 2a squared plus 3a plus 4. Then we are going to expand a plus h. We are going to have the a squared a plus h times a plus h. We have -2 bracket a squared plus 2ah plus h squared. Then the second one is 3 times a plus h plus 3a plus 3h, then plus 4. Then we are going to expand this bracket. Minus will change all the sign to the opposite inside the bracket. So -1 times -2 is positive 2a squared. Then -1 times 3a minus 3a. -1 times 4 minus 4. So here is a common mistake, easier to make. So all of them, you change the sign. Then all over h. So the above we forgot to divide by h. All over h means divide by h. So we could write it all over h or divide by h. Then continue limiting value, h approaches 0. Then we times this to each term in the bracket. So -2 times a squared is -2a squared. -2 times +2 is -4ah. -2 times h squared, -2h squared. Then plus 3a plus 3h plus 4 minus, so minus -2a squared plus 3a plus 4, we expand it. Negative sign in front, you will switch all the sign to its opposite. So negative times -2 is positive 2a squared. Then -1 times 3a is -3a. -1 times 4 is -4. Then all over h. So before this one is divided by h. Then we continue. We do this expanding, so -2 times each term in the bracket. So limiting value, as h approaches 0, we have -2a squared times 8 minus 4ah minus 2h squared. Then the 2a, 3a and 4, we could cancel them out, collect the like terms. 3a minus 3a is 0, 4 minus 4 is 0, so these two terms out. Then we are going to have plus 3h left plus 2a squared left. Then we could just divide everything by h. We use all over, instead of all over h, we divide by h to save some space. And you could continue to simplify. You can pause the video and try it by yourself. So limiting value as h approaches 0, we have collect the like terms, same variable and same degree a, and also the degree squared, they are same. We call them same like terms. So for like terms, we just add the numbers at front. -2 plus 2 give you 0. So we have -4ah minus 2h squared. Just copy these three terms down here, then divide by h. So we don't have the, we are going to divide h to both each term, three terms, each term divided by h. Then -4ah divided by h cancel out, you have -4a left. -2h squared divided by h squared divided by h, 2 minus 1 give you 1, so -2h1 left. 3h divided by h cancel out, divide is 1, so plus 3. Then you will see we don't have the denominator h equals 0. We could sub in h equals 0. So our goal is get rid of the h, because if we sub in h, then divide by 0 is undefined. So our goal is simplify, get rid of the denominators h, then we could sub in the h equals 0. Then we are going to have -4a, we sub in h here, -2 times 0 give you 0, so plus 3. This is our slope of the tangent for any points at x equals a. X value equals a give you this slope. Then we have x equals 1, so it means the a value is 1 here, so we are going to sub in a equals 1. Then we have the slope of the tangent at x equals 1 is -4 times 1 plus 3. So -4 times 1 give you -4, plus 3 give you -1. Then it's done. So you will see it doesn't matter what function is given, the procedures are same. Step 1, using the limiting value formula for the slope of tangent, then sub in the a plus h to the function, then simplify by expanding, then divide by h to each term. Then we have to substitute, sub in h equals 0, then sub in a equals 1, or based on what the x value given. So that is the x value you put in as the a value. And this is one example, and after that we are going to practice more examples. So this is another example. You could pause the video and try this question by yourself first, then after that check the answers. So this one, step 1, we know is using the limiting value formula. So limiting value as h approaches 0, f at a plus h minus f at a all over h. So remember this formula, and after that we are going to substitute the a plus h to our equation. So 2a plus h plus 4 over h minus sub in a value. So sorry, this is a plus h. Then 2a plus a plus 4 over a value. Then we don't want to write all over, we could just write it as divide by h. Then for this one, you have fraction subtraction. What we have to do is we want to combine them to one fraction by using the common denominator. So this one a plus h. This is a common denominator will be just times these two. So this first term times a value, and second term will be times a plus h. And remember, when you times a plus h to denominator then numerator, you have to times the same thing. Then after that, we have two fractions with the same common denominator. We could subtract the numerators. So we times this one to each term. So this one is 2a bracket a plus h. That is your first term for the first bracket, and plus 4 times a. Then minus 2a plus 4 times a plus h. We could use the first term times each term in the second bracket, and make sure you have the bracket there. So 2a times a, 2a squared. 2a times h is 2ah. Then 4 times each term. 4 times a is 4a. 4 times h is 4h. Then all of them divide by h. Then equals limiting value when h approaches 0. So we have a bracket a plus h. Then this times 2a squared plus 2ah plus 4a. Then we have subtraction. It means you are going to switch all the signs inside the bracket to the opposite. So minus 2a squared minus 2ah minus 4a minus 4h. So this is for the numerators, and all divide by h. Then we are going to collect the like terms, same variable, same degree. So a, same variable, 2 degree, same. So 2a squared, they are like terms. 2 minus 2, 0. So it's gone. And 2ah minus 2ah, they are 0, is gone. 4a minus 4a, 0. So only the numerator you have negative 4h left. Negative 4h over a bracket a plus h. Then divide by h, we could write it as 1 over h. So this is divide by h over 1. We change it to multiplication, we flip it. So change it to 1 over h. The reason for that is this is multiplication. We could cancel the common factor from the denominator and the numerator out. Then you will see we don't have the h by itself at denominator. So numerator times numerator, we have negative 4 times 1 times 1 give you negative 4. Denominator a times a plus h, then times 1, it will be just a times a plus h. Now we don't have h by itself at denominator. We could sub in h equals 0. Then we have negative 4 over a times a plus 0. A plus 0 is a, so we have negative 4 over a squared. And after that, the last step is sub in the a value. From here, we know this is your a value, this is your f at a. So a value is 2. Then we are going to have the slope equals negative 4 over 2 squared. So we do the exponent first. 2 squared give you 4. Negative 4 divided by 4 give you negative 1. Then this question is done. So in this question, you will see step 1, write the formula for the slope of tangent out. Then we sub in a plus h to the original function. And this one, we have the fraction subtraction. We have to find the common denominator by times these two denominators. Then remember, when you times a value to the denominator, you need to times the same thing to the numerator. Then this a divided by a cancel out. You didn't change the value of the original expression. After you have the common denominator, you just expand the numerators and collect the like terms. After that, we cancel the h out. Once we don't have the denominator with h, we sub in the h equals 0. Then we find the slope equals negative 4 over a squared. No h left. So a value is the x value of the given point. So a equals 2. We sub in. Then we have the final answer. So this is our last example. The function is f at x equals square root x. Well, at x equals 4, determine the equation of the tangent line. So it's not only the slope, but also equation. So we are going to start from the slope equals limiting value as h approaches 0. Then f at a plus h minus f at a, then all over h. So we sub in the a plus h to the given function. So it will be a plus h put here. So square root a plus h. Then a value sub in is square root a all over h. And for this question, we know that what we want to do is cancel the h out, but we don't have any h value from the numerator. So this, what we are going to do is, we are going to do the rationalizing the numerator by multiplying the conjugated term to these terms. So these two terms and the conjugated will be just change the sign for the operation sign. Minus becomes plus. So square root a plus h plus square root a. And remember, when you times one expression to the numerator, you need to do the same thing, because you don't want to change the value for the original value. So this equal sign, it means this part, what you have done, need to be 1. Times 1, then nothing changes. So you can cancel out, then it will go back to the expression of this part. So now we are going to continue. A plus 1 times a minus b times a plus b will give you a squared minus b squared. And that is why we want to do the conjugate term. This is a, you squared, you will get rid of the square root. So square root a plus h, then squared is out. So we could write it as square root, then bracket squared, minus square root, the b, then squared, all over h. Don't forget, you have square root a plus h plus square root a left for the denominator. Then we continue. to simplify the numerator. So a plus h square root squared cancel out. So we have a plus h left, and square root squared cancel out is inverse function. So minus a. Then you will see, we simplify the numerator, you will have h left. A minus a is 0, you have h left. So limiting value when h approaches 0, then we have h over h. Then we could, this is multiplication, so be careful. You only can cancel factors from numerator and the denominator. You are not able to cancel the h here. This is plus, it's not factor. So you could cancel both multiplying, so you can, we call them factor, you can cancel the factor out. Once we cancel the factor out, the denominator don't have the h by itself, we could do the sub in. So h equals 0. Then we are going to have 1 over, this is 1 bracket, square root, a plus 0. Then plus square root a. So a plus 0 give you a. So square root a plus square root a will give you 1 over 2 square root a. This is our slope of tangent for f at x equals square root x at x equals a value. So this is our a value, so we are going to sub in. A value is 4. Then we have the slope of the tangent at x equals 4 is 1 over 2 times square root 4. Square root 4 give us 2, so 2 times 2. Then we have the slope is 1 over 4. And this is the only slope. And the question asks you not only the slope, but also the equation. So the equation will be, for the straight line is mx plus b. So in these two equations, we have two parameters we want to solve. So m we know is 1 over 4. And we want to find the b. In this equation, we have 4 variables, 1, 2, 3, 4. In order to solve for b, we need to have 3 variables given. So 4 variables, we have x, y, and b, 4 variables. In one equation, in order to solve for b, we need to have 4 minus 1, 3 variables given. And how to get the 3 variables given? We have the m, we have x equals 4. We want to find the y value for this point. The y value output is, you put the 4 sub into the original function. Input is 4, f at 4 is output, is your y value. So equals square root 4. Then we have 2. So now we are going to sub in the 3 variables. So x equals 4, y equals 2, m equals 1 over 4. To the slope x, y-intercept equation. So y is 2. And m is 1 over 4. X is 4. Then plus b. So 2 equals 1/4 times 4 give you 1 equals b. Then we move the 1 to other side. We want to isolate b. Do the opposite operation, minus 1 to both sides. 1 minus 1 is 0. We have b by itself. So b is 1. Now we have the m, we have the b. We could write the equation out. Therefore, the final equation is 1 over 4x plus 1. So this is the equation of the tangent line at x equals 4 for function f at x. So for this question, what we have done is we want to find the slope of the tangent line first. Step 1, limiting value formula. Step 2, subbing a plus h to the original equation, subbing a to the original function. Then after that, because we have the square root, then we want to rationalize the numerator. The reason is we want to cancel the h at denominator out. Otherwise, we are not able to sub in h equals 0. So rationalizing the numerator by times the conjugated term. So f minus, then the conjugated term will be plus. A minus b times a plus b give you a squared minus b squared. So it's just each term squared, then minus. Expand, simplify, we have h left. H divided by h, they are factors. You are not able to divide the h from a plus h because a plus h is adding. H is not a factor. For being a factor, you need to multiplication. So h times, then you can cancel the factors out. After we don't have the h at denominator, we sub in h equals 0. Then we sub in the a value, that is the x value for the point at the tangent line. So a equals 4, we have the slope. Once we have the slope, we want to find the equation of the tangent line, that is a straight line. So y equals mx plus b. We have the slope, we need to find the b. There are 4 variables in this equation, we need 3 given. So we have x given, we want to find the y. It's just sub in the x equals 4 to find the y value. Then we have x, y, m. We have the 3 variables given, we are able to find the last variable unknown, the b value. We sub in, then we isolate the b by moving the numbers to other side, isolate b. Then we have b equals 1. Last one is the statement for the equation of the line. We sub in m and b. We have 1 over 4x plus b is 1. So that is all for this lesson. And for this lesson, learning goals is you know how to find the slope of the tangent by using a limiting value definition. And also you need to know how to find the equation of the line. Thanks for watching.